Hello. All right, we are on to our fourth unit, which is trigonometry. Today is going to be an information-based lesson as we switch from the degree units that we used in grade 11. Now in grade 12, we will be using what are called radians. Central angles and their relationship to measures of arcs. So what is that? Use that to find the measures of arcs. We multiply the radius length by the central angle in radians. Okay, so for the majority of this unit, we're going to need our calculators to be in radian mode. So if you're using an iPhone, you want it to say RAD at the top of the screen where the numbers go. If it doesn't, you'll look for that button. And if you're using a regular calculator, you'll have to go into your system setup and change it from degrees to radians. Okay, what is a radian? I'll read it and then I'll write it. A radian is a unit of angular measure at the center of a circle that relates the length of the radius and the length of an arc created from the horizontal axis. Okay, it's going to be confusing as we just look at definitions, but the more we use them in practice, the more it'll make sense. Okay, how many radians would make 360 degrees? Well, 1 radian is equal to 180 degrees, so that means 360 degrees is equal to 2 radians, and we write it as 2 pi. So 1 radian is equal to 180. So on the Cartesian plane, the graph, from x-axis all the way to the other x-axis is 1 radian. How can we use that to help us convert between radians and degrees and vice versa? So if we're going radians to degrees, you will multiply the radian degree the radial measure, sorry, by pi, then divide by 180. Okay, from degrees to radians, so the vice versa part, you'll multiply by 180, then divide by pi. And make sure we're using the pi button on your calculator, not 3.14. We want it to be as close to exact as possible. Okay, convert 3 pi over 4 to degrees. So we have 3 pi over 4. We're going from radians to degrees, so we will multiply by 180. Which gives us 540 pi over 4. Then we're going to divide by pi, which gives us 540 pi over 4 pi. And these pi's can cancel out. And 540 divided by 4 is 135 degrees. Okay, going from degrees to radians. So 25 degrees in radians, so we have 25 degrees multiplied by pi, then divided by 180. So we have 25 pi over 180. And 25 over 180 simplifies to 5 pi over 36. Okay, and I'm showing everything absolute step by step. You could just probably do the multiplying and dividing all at once. Convert 5.72 radians to degrees. Okay, 5.72 radians multiplied by pi divided by 180. And it simplifies to 5 pi over 12. Oh, my mistake, I was reading the wrong one. 5.72, my mistake for that. 5.72 times 180, we're going radians to degrees. And I'm going to just do the divide by pi all at once. So 5.72 times 180 is 1035 divided by pi, which gives me 329.45 degrees. Okay, determine the arc length which subtends a central angle of 75 degrees in a circle whose radius is 20 centimeters. Okay, so we're going to work with our angle here. We have 75 degrees. We're going to multiply by pi, then divide by 180. So we have 75 pi over 180, which simplifies. This is our 5 pi over 12. Okay. And to find arc length, which we represent as S, so arc length represented as S. S equals our radius multiplied by our radial degree. That gives us 100 pi over 12, which simplifies to 26.2 centimeters. So the general equation to find arc length is S equals the radius multiplied by theta, which is the radian degree. Okay, so S is arc length, R is the radius length, and theta is central angle in radians. Okay, and we're going to look at what principal and coterminal angles are, because you're going to come across these terms. So the a principal angle is the angle of the terminal arm that measures between 0 and 2 pi. The angle of the terminal arm Okay, so if your principal arm was what we knew in grade 11 to be 180 degrees, then your terminal arm, then your principal angle is pi. Okay, if it was at 90 degrees, that would be pi over 2, right? It's half of pi. And we're going to look at coterminal angles. And they are angles in standard position that share the same measure. As the terminal arm. Okay, so for example, 1 pi, 3 pi, 5 pi, 7 pi, etc. are all the same. Right, we think of a full circle being 2 pi. So if we went, let's think back to grade 11, if we went 180 degrees, so halfway around the circle, and then we went all the way around to 540 degrees, so that's 1.5 circles, they both represent 180 on the actual circle. So let's draw this as an example. So we have our Cartesian plane, and we're learning now that, so this is pi, 180 degrees is pi, 90 degrees is pi over 2, that makes 270 degrees, 3 pi over 2, and then the original one is 0, but then it also ends up being 2 pi if it went all the way around. Okay, so if we put our terminal arm there, okay, this is terminal arm. The principal angle would be, well, 45 degrees or pi over 4. Okay, principal angle pi over 4. But if we had an angle that went all the way around the circle and ended up there again, the exact same spot, just with gone all the way around the circle. Okay, so if we're counting by fours, 1 pi would be 4 over 4, 2 pi would be 8 over 4, and we're going another one, so this would be 9 pi over 4. They mean the same thing. Okay, so what we're getting here is pi over 4 is equal to 9 pi over 4.